how do you find the rule for a function machine? For example, what is the rule and can you prove it? In this function machine, a 4 goes in on the left and on the right, 16 comes out. If we put a 7 in on the left, out comes 19. In this lesson, you will learn how to find the rule for a function machine by using a vertical table. Let's review. Patterns. These are things that are arranged by a certain rule or a set of rules. The rules show a common difference in the pattern, such as the numbers 2, 4, 6, 8. The rule could be that we add 2 each time. But we also know that rule can be the 2 times tables, 2 times 1, or 1 group of 2, 2 times 2, 2 groups of 2, and onwards. Let's also review. How does a function machine work? This function machine might look different than the ones you've seen before, but they're pretty basic. They have a place where the number goes in, something happens, a rule in the center, and out comes the answer or the result. So in this case, 5 is going into my machine. It travels in the center of it something happens. Addition, subtraction, multiplication, division. It could be one of those items or a combination of them, and out comes the 10. So 5 goes in and 10 comes out, and we want to figure out what rule is applied to it. A common mistake. When looking at a function machine, don't stop at just one input or output. Input 3 or 4 numbers to prove the rule works on all of the input numbers. One way of figuring out the rule on a function machine is to use a vertical table. This is a vertical table. That means the numbers will grow as they go down. So on the left, you can see we have the input, or where the number goes in, and on the right is the output, and in the center is where the rule is. It's set up very much like my function machine right here. In this case, on this table, I can see a 7 goes into my machine, and a 35 comes out, an 8 goes in, and a 40 comes out. So the first thing I'm going to look at is, would addition work? Not really. On the right, the numbers are growing by 5, but on the left, the numbers are growing by 1. So I'm going to go to times tables. 7 times 5 equals 35. I will now test it on the 8. 8 times 5 is indeed 40. I think I found my rule, but I want to test some more. So I'm going to put 4 in, times 5 is 20. 5 times 5, 25. And 6 times 5 is 30. Now I can look at my table and see if my answers make sense. I can see from the features that the output is growing by 5 each time, just as if I was counting by my 5s, 5, 10, 15, and I have 20, 25, 30, and with growing by 5s, that makes perfect sense. So, using my table and looking at the list of numbers, my rule of times 5 makes sense. Let's go back to that question we asked in the beginning of the lesson. With this input machine with a 4 going in, 16 out, 7 going in, and a 19 out, what is the rule? Using my vertical table, I place the 4 in, 16 out, 7 on the bottom, and the 19 out. If I tried 4, this 4 times 4 equals 16, that might work, but this is where checking it with that second number. 7 going in, 7 times 4 is not 19. So I'll try plus 12. 4 plus 12 is 16. 7 plus 12 is 19. Looks like we might have a rule. I'm going to check. So, if the rule is plus 12, let's try 5 plus 12, 17. 6 plus 12 is 18. So on the left side of my vertical column, my numbers are growing by 1, 4, 5, 6, 7. And on the right side, my numbers are 16, 17, 18, and 19. I can see that the growth makes sense. If I'm adding the same amount to each number in sequence, it should get larger the same way in sequence. So my rule of plus 12 makes sense. It's the input plus 12. In this lesson, you learned how to find the rule for a function machine by using a vertical table.